So up to in fact previous day we were starting about this continuous state. We're starting about this continuous statement, and there we have seen that unlike break that takes you directly out of the loop, continuous statement takes you to this updation part of the for loop, okay? Or in fact the beginning of the loop. Now and whenever for loop comes back to the beginning of the loop, as we have seen that it is the first updation occurs and then the condition occurs. So when continue comes back to the beginning of the loop, it is the updation that occurs. Now we have also shown a demonstration about how a break would work here and how a continue works here. Let me write a small code to demonstrate these two facts. Let me create a new document. And here, suppose I am creating a loop in which I am writing, say, before b I, then if I is equal to 3, I'm writing a break, and then after I and at the end of the for loop, label I as global after for loop. That's I. Now, if we execute this, now as you can see that as we have demonstrated yesterday, before 0 it's not matching, so break will not be executed. After 0, then before 1, after 1, before 2, after 2. Then when I becomes 3, before 3 gets executed. When I becomes 3, this condition is true, so break gets executed, and as soon as break gets executed, the control comes immediately after the for loop. That means the loop ends immediately. And when the loop ends, what was the value of I? 3, because with the value of 3, the loop ended. So after for loop, the value of I gets printed as 3, right? Whereas if I use continue statement, the behavior will change something like this. Okay. Before 0, after 0, like that, before up all the way up to before 2, after 2, the behavior is same. Right? Before 2, after 2, the behavior is same. Now when I becomes 3, before 3 gets printed. But as soon as I is equal to 3, this condition gets satisfied, continue gets executed. Break to the control directly here, continue takes the control directly to this for loop line. That means the first line of the for loop. Okay, or the defining line of the for loop. Rather, we'll call the first line of the for loop as this one. This is the defining line of the for loop. Continue takes it directly to this defining line of the for loop, and just like that particular execution of the block has finished, right? And the next part, whatever was after that, in the continue in the block, did not get executed. So it came here directly. I was 3, so I increments to 4 naturally, and again before 4, after 4, that gets executed. Then because when I is 4, this continue does not get executed again. Then I becomes 5, and this condition is false, so it comes here with the value of 5. So after for loop, 5 gets printed. Okay, so that's the behavior of continue. Continue takes you directly to the defining line of the loop, just like that particular block, just like that particular execution of that loop block has finished, and it is preparing for the next execution of the loop again. Whereas break also assumes that on the execution of break, it is also assumed that particular execution of block has finished, but it does not go to the defining line of the loop for the next to be ready for the next execution. Rather, it goes directly outside of the loop itself. Okay, so is it clear to all of you, this break and continue? Any of you have any confusion here? Okay, now one thing that needs to be mentioned here is that bolo.
Sir, what if we write I is lesser than 4?
I is less than 4. It's 1.
No, sir, in the condition for the for loop.
Okay, the condition for loop. I is equal to 3. Let's think step by step again. We're not going to execute it first. Let's think step by step. Before 0, after 0, all the way up to before 2, after 2 gets executed normally. Now I becomes 3. Before 3 gets executed, continue gets executed, right? So it comes here. I becomes 4. This condition is false, so it goes directly here. So before 3, then directly here after for loop 4. Is it clear whatever I said? Let me write it here. Suppose I am going to make this 4, and at I is equal to 3, I am going to make it continue. So, okay, this was going to be executed. Let me tell you. So, A0, A0, B0. Suppose this line is here. Printf. And here, after printf, I am doing another print of I. Obviously, considering that I is declared previously. So A0, B0 gets printed, then A1, B1, A2, B2, normally as it is. Then I becomes 3. A3 will be printed normally, right? Now this condition is satisfied. Continue. Continue will take you to the defining line of the for loop. What will be the I? What will be the value of I now? 4, right? Now this condition is false. After incrementing, it goes to the condition checking. This condition is false, so it goes directly here. So printf, this after for loop 4 will be printed just. Is it clear?
Yes, sir.
Let me show this. So you can see before 3, immediately after for loop 4 got printed. Okay. So any other query regarding break and continue? Okay. So now, okay. So what I also want to mention is that continue as last statement. I think this is what I was going to write previously. Continue as last statement is meaningless. Never use that. That's an example of bad programming. Because if continue is the last statement, suppose this statement is not there. Now, this is simply meaningless. Doesn't matter whether continue executes here or not, it will anyway go here. So this overall thing is meaningless at this moment. As you can see, it will naturally execute before 0, before 1, before 2, before 3, and after for loop 4. Just like continue is not there. So continue as the last statement is always meaningless. Never use that. Because it is anyway taking you to the first statement of the loop, which you'd anyway got there, which you'd anyway get there after the current execution of the loop. Now, with that said, now we have seen this structure of the for loop, right? Initialization. Let me write it in init shorthand, then condition, and then updation. If we wish, we can omit any one of them, or in fact all three of them. In fact, we can omit any of them, right? Each of them are conditional. Each of them are optional. Okay, but things to remember here is that if condition is omitted, it is always regarded as true. It is always considered true. So, does not matter whatever you write, whatever initialization you give, whatever updation you give, but if you do not give the condition, this will create an infinite loop. Because whenever it will come to check the condition, does not matter how the variable has been updated, does not matter how the variable has been initialized or anything here, condition will always be true. So this block will always be executed. So this is going to create an infinite loop. So if you are really trying to create an infinite loop, why is the reason of providing init and updation anyway? Right? Because they were not going to work anyway. Right? So until and unless you are using it inside the loop. So remove them as well. This is the most common method of creating infinite loop. A common method of creating infinite loop. Okay, now let me show this. Let's see that stuck immediately after this. For you can see it is stuck here because it is executing. It is stuck in this infinite loop forever. Infinite loops are extremely important in several scenarios where maybe the condition is difficult to express within a single statement or anything like that. So what in that case we generally do is we create an infinite loop, and on that particular condition, after writing that extremely complex condition, maybe the condition is coming after several amount of steps, after that condition we just simply just put a break. Okay, that's a good use of infinite loop. Now it is generally used when condition is difficult to express as a single statement. Okay, use break in the case of infinite loop in that scenario. Okay, now
Sir,
bolo.
a question, sir. Sir,
Bolo.
let's say we are using a for loop, infinite for loop,
Hmm.
but we have given initialization and updation. Okay, sir.
Uh, uh,
And so, sir, now if we use some condition for, let's say, 23 times we want to execute the for loop,
hmm.
then the time for 23 time executing in giving condition and without giving condition will be same or different, sir?
It will be almost same. This is 23 times it will execute, right?
Yes,
If
sir.
I provide this 23 times execute. Now, in the condition, what I'm going to do is, let me show this with a small value rather than 23. Let me show this with, say, okay, 23 is also not a great value, very high value. If I is equal to 23, provide break. As soon as I will reach 23, it will break. Before that, let me print the value of, or maybe after print the value of this one. Okay. And you'll see that this is going to give you the same output. Let me comment this one. 0 to 22 it printed, right? This is exactly the same you'd have by providing I less than 23. Okay. Is it clear whatever I said?
Yes, sir.
Whenever I is going to reach 23, break it without printing it. So after printing up to 22, whenever I became 23, it broke out of the loop. Okay. Otherwise, if you would not provide this, then new line, let me put a space. I stopped it using Control C. Okay. See, pretty soon from I is equal to 0, where it has reached 11,83,616, and it was continuing. So, but obviously, in that example, when this condition is extremely difficult to express this as a single statement like this, okay, when the condition is not so much simple, always use an infinite loop and use break after that. Well, any other query? Now we can also omit the initialization part as well if we wish. So as for example, uh, suppose I is less than 23 and I'm omitting this one, and I'm omitting the initialization part as well. I is equal to 0. So if you're omitting the initialization, in case of omitting initialization, provide it before loop, and this will also do the same thing. It's just like, that means int I is equal to 0 written here. Okay, and in fact in the previous day in this primality testing program, here we have declared I only here. In fact we could have written, in fact we generally write, we initialize it on this very same line and we omit this one. So that's also a pretty common program. I will anyway initialize from 2 by default. Now, so we can omit initialization also. If we wish, we can also omit the updation part as well. Omitting initialization was pretty obvious. Sometimes updation is also not easy to describe in a single statement. Maybe I is getting the next value not by a single increment of something, rather it is getting the next value after a complex sequence of operations, or maybe it is getting the next value upon certain conditions. Okay, so in those cases you cannot provide the updation in the defining line of the for loop, right? So when updation is difficult to be represented as single line or as single statement, or updation is conditional, that means you are updating value uh, based upon some condition. Updation is conditional, uh, we can omit condition. Problem in network. Omit condition. There is a problem in network. There is a problem in my Wacom tablet. Well, and provided within loop body. In fact, omit condition from the defining line of the loop. Okay, so here, as for example, I can provide I++, and this will also do the same thing, because here I have omitted the updation and I have provided the updation here. But now it may happen that this updation is some conditional. As for example, maybe if I is, I'm just taking a random example. Suppose if I is even, update it by 1, otherwise update it by say 2. Just taking an example. You cannot represent, though it is not practically useful, you cannot represent such updation within this line. Okay. So in that case, you have to employ omit the updation from here. I have written omit condition. Provide the updation from here and provide it within the body of the loop. This is going to print only the odd numbers. Okay, starting from 0. So now, any of you have any query at this moment? Now, the fact is, when you are omitting both the updation and initialization and putting only condition, here is another construct for that. Omitting both updation or both initialization and updation from for has another loop construct. That is what we call while. Okay, and its structure is simply while within bracket condition. So see, while does not, while only accepts condition. It does not provide you to write the updation or the initialization or updation here. Okay, but there are several other constructs of while loop. I'll come to that point. So if you provide while here, but obviously there will be no semicolon because it takes only a condition, and this will do the same thing. You'll get the same output as this. Okay, so while condition, now suppose this is block B1. B1 is executed as long as condition is true. Whenever condition will be false, it will come out of the while loop. Now, you cannot omit condition from here. Bolo? Some of you is unmuted. If you have nothing to ask, kindly mute yourself. So, see, just you have seen that if we omit the condition in the for loop, it gives us an infinite loop. But you cannot omit condition from the while loop. But while one, if you provide this is another good way of providing infinite loop. One means true, right? One always means true. So this condition always, that means this condition is always true, and this loop is going to execute forever. It is printing continuously all the odd numbers, and I stopped it using Control C again. So while one is giving you another way of creating infinite loop. If you are doing in C++, at the place of 1, we generally write true. Okay. 1 is at the place of 1, we generally write true. Here, because there these true, false, etc. available, but here to provide true, you have to use the bool structure. So std bool.h had to be invoked, and true only after that you can write the true. Or you can define true yourself as well. Without this std bool.h, true is not defined. In fact, it is suggesting true is defined in std bool.h. Did you forget to include this true undeclared? Today's compilers are way much advanced. Well, so that's about the while loop. If you have understood the for loop, while loop is not difficult to understand. This is simply the while loop. B1 will be executed as long as the condition is true. But here, the fact is, let me write a code. While I is less than 5, printf I, and let I get increased by 2. In fact, as you can understand, that it will print simply 0, 2, and 4. Right? Now, suppose the value of I am making it as 6 and or 5, anything, something greater than or is equal to 5. This loop is never going to be executed. Okay, because whenever it tries to enter the loop, it first checks the condition. If the condition is true, then it executed. So while loop, what it does is that when you are writing while condition b1, the property here is that first condition will be checked, will be checked, and then loop will be executed. And if condition is false from the very first end, the loop will never execute. So there comes another construct, do then a block b1, certain block, and while condition. You have to provide a semicolon after this, don't forget. In the case of do while, there is no semicolon after while, or there is no semicolon after for, but after do while there is a semicolon. Here first b1 will be executed, first b1 will be executed, and then condition will be checked. And if the condition is true, next time b1 will be executed again, and so on. So you can think here something like this. Suppose b1 has executed here 2 times, then you can also be sure that the condition has been checked 2 times. Whereas if b1 is executing for the second time, that means condition has been checked only once till now. Is it clear? First b1 executed, then condition got checked, then b1 is executing again based upon the previous condition. Then after executing b1, it will check the condition again for the next execution, right? So the sequence here is execute, check, execute, check, and so on. Whereas the sequence in the case of while loop is first check the condition, then execute, then check the condition, then execute, and so on. Okay, let me show this. And as you can see, the loop has not been executed because the condition got first checked, condition was false, so it came out of the while loop immediately. Whereas let me write it here. And as you can see, 6 got printed, even though this condition is false. This condition is false. So printf I, this 6 got printed. Then I becomes 8, and then this while loop is checked. 8 is not less than 5. It is false. That's why it get out of the loop. But it got executed at least once. And if I give 0, you'll see the same output. Okay. Because it first printed 0, then I became 2. 2 is still less than 5. It printed 2. I became 4. 4 is still less than 5. It printed 4. Then I becomes 6. then it is checked. 6 is not less than that, not less than 5. So while loop is false. Sorry, this while condition is false. It goes out. So in normal scenario, you're not being able to see the difference here, but in many complex cases, in many scenarios, it becomes important that uh, that we check the condition after executing. Maybe during the execution, certain certain events happen that we need to ensure that before the next execution that needs to be checked. So we put this into a do while and check that particular condition at the end after execution. Maybe what I said may seem complex at this moment, but you will understand its importance when you. And Python has shown that program can be written without do while. The fact is, it is not mandatory. You can even simulate this behavior using a while loop as well. But in several scenarios, do while just makes it easy. Okay. Is it clear whatever I said?
Sir, you were audible for some time. Can you repeat?
Uh, when I was not audible, what was the
Uh,
last thing you heard?
Sir, last thing I forgot, but then you started with a Python and something.
Okay, okay. See, uh, what I said here is that the do while is very important in later on when you do some professional programming and shorts. You'll see that you in certain scenarios you simply cannot avoid do while. But the fact is, it is not mandatory. You can write any program without using do while. Python has shown that because Python does not have do while. You can simulate this same behavior using while loop as well. Okay, just you have to initialize the variables properly, just you have to do the operations properly. But there are several scenarios where do while just makes it easy. Is it clear? Is it clear whatever I said? Anyone?
Yes, sir.
Okay, so any of you have any question till now regarding loops? Then I'll go to the next phase, a bit complex structure of the loops. Okay, the fact is, in these constructs, as for example, just one second. Okay, there is certain constructs. As for example, suppose if I write, if we wish, we can initialize multiple variables within the for loop and work with multiple variables in the for loop. Suppose for I'm writing int I is equal to 0, j is equal to 3, and maybe we can write say I less than is equal to j, I plus plus, j minus minus. Printf %d I plus j. Now what is happening here? Here you can see that we have declared two variables at once within the for loop. In fact, as I mentioned previously, this initialization part will be made only once. So I gets initialized to 0, j gets initialized to 3. Now I less than is equal to j is satisfied because 0 is less than 3. So the block executes. So first 0 plus 3, 3 gets printed. Now after printing 3, this will come here. I will be incremented to 1. At the same time, j will be incremented to 2. Because these both statements will be executed one after another. First I plus plus will be executed, it is a comma. I plus plus will be executed, then j minus minus will be executed. So both will be executed. So I plus 1, j is equal to, I will be 1, j is equal to 2. Okay. It is still satisfying because 1 is less than 2. So 1 plus 2, 3 will be executed, 3 will be printed again. After printing, it will go back here again. I will become 2, j will become 1. Now this condition is false because 2 is not less than 1. So it will go out of the for loop and only 2 3s will be printed. Let me show this with an example. And if you execute this, you can see 3 gets printed 2 times. Because both, let me show that how I and j are changing simultaneously. So I'm printing I, j, and I plus z all together. Initially, it started with 0, 3, where sum was 3. Then, when it executed, these two statements got executed one after another atomically. So I got executed, j got decremented, I got incremented, j got decremented. I becomes 1, j becomes 2. And this condition is still true. So it is executed again. Then again, these two statements are executed simultaneously. I becomes 2, j becomes 1. And it is false now, so it goes out of the loop. So what it shows is that we can use multiple variables. We can initialize multiple variables I initialize multiple variables and update them together. Okay. Now there are multiple variations you can do here. Maybe suppose you can just put the initialization of j within the loop body. Maybe that if I percent 3 is equal to 0, then j gets incremented. Let's see. First, whenever you see a program, first do a pen and paper simulation, and you'll understand how it is behaving. So suppose for int I is equal to 0, j is equal to 3, I less than is equal to j. I am putting only I plus plus here, and I am not incrementing j. Sorry, I am not put it j minus minus. and let me start it with I plus plus here only, and maybe here I am printing I plus j. I'm writing it in shorthand now for quickly. Print I plus j simply. But next statement, if I percent 3 is equal to 0, that means whenever I will be divisible by 3, just decrement j. Now see what will happen. I is equal to 0 and j is 5. This condition is true, so it will come here. 5 will be printed. This is my printing out. Now I percent 3 is 0, so j gets decremented to 4, right? Then after executing this, I gets incremented 1. J is still at 4. Observe, this is less than j, so it is satisfied. So 5 will be printed again, right? I percent 3 is false, so j minus minus will not be executed. Then I becomes 2. Okay. Then I becomes 2. It is still satisfying because 2 is less than or equal to 4. I plus j, that means 6 will be printed. Then I percent 3 will be checked. It is still not divisible by 3 because I is 2 at this moment. So it will not be executed again. I plus plus, that means it will again go to the defining statement. I plus plus, that is 3. 3 is still less than 4. So I plus j, 7 will be printed. Now I percent 3 is, this condition is satisfied. So j becomes 3. Okay. Then I plus plus, I becomes 4. Now I is 4 and j is 3. So it is not satisfying, right? Because 4 is not less than 3. So it will go out of the for loop. So the output will be 5, 5, 6, 7. Always practice such pen and paper simulation to understand the behavior of any program. 5, 5, 6, 7. And these are the corresponding value of I and j's that it was taking step by step. So you can initialize any variables, you can update any variables. In fact, if you wish, that it is not necessary that you will be able to update only those variables that is being declared via for loop. In fact, if you wish, maybe you could have initialized priorly as well, and maybe you can decrement it at the same time. This will perform the same execution. Okay, but obviously, the new behavior, you have to check that out again by pen and paper simulation. Okay, so what I just wanted to show here is that you can perform updation of multiple variables at once. You can perform initialization of multiple variables at once, or you can perform some initialization before, some updation within the loop body, anything. It is just depending, it just depends on the requirement of your project, requirement of the software, or requirement of the algorithm. Is the concept clear to all of you? Any of you have any query? Now, nested loop. We can use loop within loop. Suppose I am writing something like for int I is equal to 0, I less than 3, I plus plus, for int j is equal to 0, j less than 2, j plus plus. See, this for loop is within this for loop, and here I'm going to print suppose I plus j, and here suppose I'm going to print a new line. Here I'm going to print a new line. Now how is it going to perform? See, now this is nested loop. That means this is what we'll call outer loop, and within this outer loop, this is our inner loop, right? Because this for has only a single statement within it. So in fact, this printf is coming within this outer loop. Okay. Now how it is executing? First I is equal to 0. First execution starts with I is equal to 0, right? Now in the case of I is equal to 0, now this for loop starts. J is equal to 0. Now this for loop starts, j is equal to 0, I plus j, so 0 is printed. Rather than new line, let me give a space here. Suppose this is a space. Okay. Now, so 0 is printed. Now, when this print will be done, it will not jump back here. This loop is still not complete. It is an inner loop. And this printf belongs to this inner loop. So j is incremented to 1. See, now I and j are not incrementing simultaneously now, because it is loop within a loop. Whereas this one, it was a single loop where two variables are being incremented simultaneously. It is a loop within a loop. So first inner loop will be performed. This consider this, it is a block within a block, right? If you have certain block, and then within that block you have another block B2, and then some statements, and maybe another block B3. This is outer block. For this outer block, first B2 will be performed, then the statements will be performed, then the B3 will be performed, then this block, then the execution of this block will be considered completed. Then it will, if it is a loop, it will come back here or something like that. Then the properties of B1 will be satisfied. Properties of B1 will be followed then. But first, the internal blocks needs to be executed. So now j becomes 1. Again I plus j, 1 will be printed. Now j becomes 2. This condition is false. Sorry, there is not a new line, there is a space. 1 will be printed here. Now j becomes 2, and this condition is false, so it goes out of the for loop. Now inner for loop, it goes out of this inner for loop. So this control will come here. That will simply print a new line. So the cursor will come here. Okay. Now after printing this new line, now this outer for loop is completed. Now this outer for loop is completed. Now that means one execution of the outer for loop is done. Now the next execution of outer for loop will start with I is equal to 1. With I is equal to 1, now the inner for loop will again start its execution. J is equal to 0. So 1 plus 0, 1 will be printed. Then j will be 1. So 1 plus 1, 2 will be printed. Inner for loop done again. J becomes 2, and inner for loop is failed again, right? So it will go after the inner for loop, new line will be printed. Cursor is here. Now once the cursor is printed, once the new line is printed, another execution of the outer for loop is completed. Now, and it is waiting for the next execution of the outer for loop. So I is equal to 2, right? I is incremented again. For I is equal to 2, j again starts from 0. So 2 plus 0, 2, right? J becomes 1. 2 plus 1, 3. And j becomes 2. and it is false again. So it will go out, it will go out of the inner for loop, and this new line will be printed. Cursor will be here. Now I will become 3. So the third execution of the outer for loop done. I will become 3. Now this condition is false, it will go directly out of this for loop. So this will be the output. Okay. Let me show a brief execution of what I have done here. This is 0, 1, 1, 2, 2, 3. Okay. So any of you have any queries till now? In fact,
सर फिर से
बोलो.
एक्सप्लेन कर दीजिए.
This nested for loop.
यस सर, नेस्टेड सर, जो आपने अभी आईजे का वैल्यू जो एक्सटेंड करके बताया ना सर, वही सर फिर से.
हाँ. Okay. See, nested for loop means loop within another loop. Okay, it is not only for loop, it will work on any loop. Just keep in mind that this is one separate loop, this is one loop that is just working within this loop. So consider something like this. This is your main loop, I is equal to 0. So it starts from I is equal to 0. Now from I is equal to 0, this inner block will, sorry, not inner block, this outer block will be executed, this complete block will be executed, right? Consider other than the for, if there would be anything else, this complete block will be executed for I is equal to 0, right? But in this case, as a part of that block, there is a for loop itself. So this will be executed for I is equal to 0. So I is equal to 0, first this for loop needs to be completed. So j is equal to 0. It starts from j is equal to 0. I plus j is printed, 0 is printed here. Then j is incremented. See, it will not increment I, because first see. Now forget about this line. This for loop is executing now. So j will become 1. So 0 plus 1, 1 will be printed. J becomes 2. This condition is false. Now it goes out of the for loop, right? And new line is printed here. Now once this new line is printed, now this complete block is done. Let me do it in a different color. This is the outer block. Now this block is done, and once this block is done, just like all the other loops, once the block is done, then it goes back to the main loop. So I here becomes 1 now. Now for I is equal to 1, this will restart again. That means this block will be executed again for I is equal to 1. Is it clear till now?
Yes sir, yes sir.
Now, so this will execute again. So again it starts from j is equal to 0. Just like this block executes simply again, because this condition is still true, right? So j is equal to 0. So 1 plus 0, 1. J becomes 1. 1 plus 1, 2. Now j becomes 2. It is false again. So it goes here again. New line is printed. Cursor comes here. And once this new line is also printed, that means this statement is done. This block will be this execution of this block is done again. So now I will become 2. For I is equal to 2, this condition is still true. So it will again enter this green block, and so this for loop will start execution again. So j is equal to 0. 2 will be printed. Then j becomes 1. 3 will be printed. It is false again. So this inner for loop will go out and new line will be printed. Cursor is here. Now this green block executed again. I becomes now 4. sorry, I becomes now 3, and this condition is now false, it will go out of the for loop. This main for loop, outer for loop. Is it clear?
Yes, sir. Thank you.
Welcome. Just write it one loop within another loop. Just remember that the inner loop is just nothing but a part of the outer loop, and that will be executed just like independent of the outer loop. Okay.
Sir, if I choose instead of I plus I, if I choose, तो what happened, sir?
This, if you write plus plus I,
Yes, sir.
there will be no difference, because this is a standalone statement, right? This is just a standalone statement. So plus plus I and I plus plus will show you the same behavior. If you do here, you'll see the same behavior, because this is a standalone statement. I plus plus and plus plus I, they are both same. You can use anyone. Okay. Any other query?
No, sir.
Okay.
Sir, can we leave, sir? Another class is
Yeah.
there.
Yeah. Sure. We'll see you again at 5 to 6 class. So I'm stopping the sharing and I'm stopping the recording.